Hello everyone, this is How I Love Geometry. I'm Mr. Chao. This problem is from 2022 Aime12, problem number 11. Let A, B, C, D be a convex quadrilateral with AB equals 2, AD equals 7, and CD equals 3, such that the bisectors of acute angle DAB, that's angle bisector, and angle ADC also angle bisector, intersect at the middle point of BC. So M is the middle point of BC. Find the square of the area of ABCD. So we want to find the area of ABCD. So here, it's very special is M is a middle point, and this is AM and DM angle bisector. So regularly, when we saw this angle bisector, we think about which one. Yeah, I want to get congruent triangles, right? So I will find a point on AD. Let A, so here, let me say this is S. Let AS also equals 2. So when we connect M and S, this triangle, I mean ASM congruent ABM, right? Why we need this one? Because now this is two congruent triangles, and this equals this one, and the same thing we will do for this one, and we will find a point T. Let DT equals 3 equals DC. So when we connect them, now we see this is 3, right? And this is 2. So total is 7, this is 5, so this is also 2. Now is a isosceles triangle for triangle SMT. Yeah. So this triangle congruent to this triangle, I mean DTM, and the triangle DCM. And of course this angle congruent to this angle congruent to this angle. Now this is isosceles triangle. Then we will do the perpendicular segment, or we can say altitude or height, from M to the AD. So we call them, this height is H, okay? And let's go, this is the H, point is the H. So MH is, this is SMT. Now SMT is an isosceles triangle, right? A lot of properties we can use, because this angle congruent to this angle, right? So it means this angle, right, congruent to this angle, and also congruent to this one, So it means this angle congruent to this angle, and this one and this one, the sum, they are supplementary. So it means, let us say this is alpha and beta. So at this time, alpha plus beta is 180 degrees, right? Because this alpha, this is also beta now. This is beta, this is also beta. So it means M, S, D, C, these 4 points, they are on the same circle. So we call them MSDC is a cyclic quadrilateral, right? If they are cyclic quadrilateral, then what can we use to help us to find the area of this ABCD? We know now that all of the focus all of them is focused on how to find the height of edge, right? If we got edge, we know this is 2. We can easily to find AB area of ABMS, right? Because the area of ASM equals area of ABM, and the base is 2. If we can find the height of edge, so easy to got. The same thing for this one, for TMD and triangle at CDM, right? And also we can easily to find the area of STM. So edge is the most important thing we should to find. So if we wanted to get edge, we know SH is 1 and HT also is 1. Total is 7, 2 and 3. So this was 1, 1. And let us suppose MS is D. Okay. Also this is D. So this is a right triangle, right? I mean MHS right triangle. If we can find D, we will find the edge, right? Because we just find the edge. Yeah, we don't know AM and MD, right? We know AS, yeah, but if we don't, it's not easy to find AM, right? Now we want to find the D, so the cyclic quadrilateral for SMCD maybe can help us something, because we know alpha and beta supplementary. So also this angle and this angle are supplementary. So it means this angle, I mean angle ADC equals the angle SMB, right? Yes. All of this one plus this one is 180 degree, right? And this one, this angle, so SMB, yeah, plus the angle SMC is 180 degree, right? So, and this one and plus this one equals 180 degree. So it means this angle, and we know the angle, which one? We will write down here the angle AMS, this angle congruent to this angle which one? ADM. And we know this is beta, right? This is beta. So the triangle AMS similar to the triangle AMS, similar to the triangle the MDT, right? MDT, because this is A and this is M, and this angle and this angle and this angle and this angle. So we will find which one? MS over MS is D over DT, over DT, that's 3, equals this, we will use MT, right? So AS equals 2, and MT also D. So we will get D squared equals to 6. Then we will get H squared equals which one? Equals 6 minus 1, right? D t squared minus this sh squared, so that's 5. And we know h equals square root of 5. Then we know this area, so total area ABCD equals 2 of this one, that's 2h, that's for ASMB, and plus SMT, that's 1h, and the area of this TDCM, that's 3h, so equals 6h, so equals 6 square root of 5. And finally ABCD squared equals this squared, 6 square root of 5 squared, that's 180, right? 36 times 5, yes. It's done, right? We find the area of the square of the area of ABCD. But this problem, all of them, is very important for this one. We find this triangle, right, similar to this triangle. And you here I just wanted to introduce another way. Here is y1, and we can use another way to get the final answer, because not always we can easily to find these two triangles similar. If we can't find this one, how to solve this problem? Because we should use the property, this is an angle bisector, and that's midpoint, so we easily to find to build all of the total, the total triangle of this one. So let us call this is P, okay? We will extended AB, and extended DC. They will meet the point P, or intersect point P. So if we connect this PM, we know this angle is beta, this is also beta, right? And so this angle and this angle, they are equals, right? They are equals. So this is an triangle PBC. Triangle PBC is an isosceles triangle. So, and also we find this triangle, because this is alpha, right? Because this is beta, that's beta, so this is alpha. It means this triangle is similar to the triangle MST, right? Yes, triangle also similar to this triangle, because they are isosceles triangle, and this angle also alpha, right? So if the corresponding part will have the same ratio, so this is 1, and this is also D, right? If we say MS is D, BM is D, because this triangle congruent to this triangle, so this is also D. So BM over SH is D times, so BP also will be D times, so D times D, so D squared, also D squared. And here is H, it will be DH. Now we can use this to solve, because to find the D or H, because we know D squared equals H squared plus 1, right? And so we want to find, because we need this angle, we can use cosine law, because we can use this small triangle MST to find the cosine angle SMT. So we can call this angle is theta. So we can call this theta. So according to the cosine law, we will got this is 2 squared equals d squared plus d squared, right? Minus 2d squared cosine theta. So each side divided by 2, we will got d squared cosine theta, right? D squared cosine theta equals d squared minus 2, right? And then we will calculate cosine theta equals d squared minus 2 over d squared. So that's cosine theta. We can use this to express cosine theta. Okay, now we will use this cosine law for the triangle ADP. So we've got AD squared, that's 7 squared equals 2 plus d squared, then squared, right? This side squared plus d squared plus 3 squared minus 2 times which this side 2 plus d squared and times this 3 plus d squared, then times cosine theta, right? Cosine theta, that's this here, d squared minus 2 over d squared. We can use this parenthesis, right? Now what we should do is to solve this equation, right? To solve this equation. So what we can do, that's 49, right? 49 equals, this one is 4 plus 2 times this, so 4d squared plus d to the fourth power plus so 9 plus 6d squared plus d to the fourth power. Then we will try this one, right? And first we can times this one and this one, so that's d to the fourth power, right? And that's 3 and that's 2, so plus 5 times d squared plus 2 times 3, that's 6, right? Here is, there is 2. Also we can try this one here. This 2 can times here, 2d squared minus 4, right? And over d squared. So we can times d squared for each side, and it will got 49 d squared, right? And we can plus this one. So 49 d squared each side, every term times d squared. So and then we will plus this one, and d to the fourth power plus 5d squared plus 6 times 2d squared minus 4, and here we got 4 2d, this one and this one to the fourth, then times d squared, so 2d to the sixth power, right? And now we will got this one, that's 10, right? Plus 10d to the fourth power, and plus 4 plus 9, 13d squared, right? So here, if we want to go ahead, we can let t squared equals t. Then we will find 49t and plus, that's t squared plus 5t plus 6, then 2t minus 4 equals 2t to the third cubic plus 10t squared plus 13t, right? And we will extend it to this one, 49t plus 2t cubic, right? Now minus 4t squared, this one, and then plus 10t squared, then minus 20t, now plus 12t minus 24 equals 2t cubic plus 10t plus 13t. Then we will find this one, and this one. Then nothing. So what was left? Finally, what was left? We will got finally, and we will combine the like term and then divide it by 4. Finally, we will got t squared negative 4t squared plus 28t minus 24 equals 0. And then we can got t squared minus 7t plus 6 equals 0. Then we can factorization like t minus 6, then times t minus 1 equals 0. So we can got t equals 6 and t equals to 1. T equals 1, it means t squared equals 1. Then h squared will be 0. No, we will reject this answer. And then we know t equals 6. So t equals 6 means t squared equals 6. It will be the same answer for the v1. Then we know h squared equals 5, right? Finally, we will find the final answer, 6 square root of 5, then squared equals 180. Done. Also done. So, and the V2 is much more complicated because we used a very complicated equation. We're lucky we can solve this equation and find the same answer finally. So sometimes a lot of geometry problems have many different ways to solve it. I believe that must have different ways to solve this. I just show you 2 ways. Okay, the first one is the best. I think is the simplest one because we are lucky to find the triangles, they are similar. So, and I think the most important idea, all of them just from the angle bisector, this angle bisector, this angle bisector. So in the way to I think about to make this isosceles triangle, just because if we find this vertex and connect this midpoint P, also well angle bisector, right? We know the 3 interior angles bisector, they were concurrent to 1 point. Then we will find the midpoint and angle bisector, yeah, must be isosceles triangle. So then if isosceles triangle, we can use a lot of properties. Yeah, I think that's important. Thank you. Hope you enjoy it.